So we know that. So Manny told us that if we bought 4 top 10 ringtones and 1 premium ringtone, it's $13.50, and we have $15 to spend. So we know that that's in the criteria that we can buy that many, but it's not the only answer.
Who knows another one? This is where you can jump in. What else could we do? What else could we buy?
Oh wait, yeah. You could buy 4 ringtones, premium, and 2 top 10.
So we bought 4 premium and 2 top 10. How much are we spending?
It would be $6 for top 10 and $6 for premium, so $12 total. That works as well. Could you come up with another combination? Yeah, there's a range, okay? Because you already identified here that you're dealing with an inequality. Good.
So this is what it's going to look like. I know it's a little scary right now, but this is what it's going to look like when we graph it, which we're going to ease into it. Don't worry. So if our coordinates, our x's represented the number of premium ringtones, and our y's represented the number of top 10 ringtones, these are a bunch of the coordinates that work.
You already identified that there's not just one value. It's actually multiple. It's a range. That's a system of inequalities. Okay, so it's the same concept as a system of equations, but you're dealing now with not just, think about what a system of equations meant. When we were dealing with just an equation, where's the solution to an equation? If I'm graphing it? Just, no, the solution to just one equation. How do we represent the solutions to a linear equation? Where do they fall?
On the points of the line.
They're the points of the line. Okay, but now we're going to transition our thoughts. We're not going to think just about an equation. We're going to think about an inequality. Think back to what you know about a regular inequality, like x is less than 3. So let's deal with the equation, x equals 3, and then the inequality x is less than 3. If I graphed this on a number line, where's my solution? It's at the point 3. If I graph this one, where's my solution?
It's at the point 3, but it's not including 3.
So what would it look like if I had to graph that on another line?
A circle around 3.
Okay, so shaded or not?
Not shaded.
Why would we shade it?
Because if it was equal to
Right, if you had that equal to symbol, you would shade, but since it's just less than 3, it's any value less. How do I show the solution? What are the values on the number line that are less than 3? Which way? Everything this way. So I shade it. The idea of a system of inequalities is the same. It's the same idea. This would be the line, but this is like the range. So we're dealing with like a whole bunch of solutions. So today we're going to do a few things. We're introducing systems of inequalities, but we're going to kind of break it down, starting with just graphing a linear inequality, like y is less than 2x plus 3. Because we have not graphed them yet. We're going to start with that. Then we're going to put them together. So this is where we accelerate a little bit because this is Algebra 1. This is not 8th grade math anymore. Okay? So write this down.
Yeah. A system of linear inequalities is made up of 2 or more linear inequalities. So a solution of a system of linear inequalities is an ordered pair that makes all the inequalities in the system true.
That's really the same concept as the solution of a system of equations. When we talk about the solution to a system of equations, we're looking for the coordinates that they share. It's the same thing here, except now when you deal with inequalities, your solutions aren't just on the line, or they may not be on the line at all. They're really that range. We're going to spend some time. It's actually really fun graphing systems of inequalities with colors.
It's not just the one coordinate now. It's a range. It's a set of coordinates. Because there's multiple solutions. It's going to represent all of the solutions in the system.
there are some of the activities actually have to use color. No, because I don't want them to focus on the color. I want them to focus on graphing. Because if they don't know how to graph, they can get color. So we'll start by graphing just one linear inequality, and then we'll build up to graphing the two together. The system. If you don't, I know a lot of you have it fully written. If you don't, just grab it from someone who's next to you, because I know at least one person in each area is finished writing.
Alright, so we're gonna start. So this is a system of inequalities, but we're gonna start just by graphing like the first one. Because we haven't graphed any inequalities yet, so we're gonna work with just one for right now. So y is less than 2x minus 3. So think about how we've graphed just a line in the past. There's multiple ways that we've learned. How can we find?
You can substitute x in for 1.
Yeah, so we can substitute a point. So we can substitute if x is 1, we can find y. So in this one, if x is 1, what is y? Alright, and another point. What's something else?
0.
Alright, so if x is 0, y is negative 3. Okay, so when we graph a line, when we graph an inequality, alright, so think about when we graphed over here. We didn't shade in the circle because why?
It's not equal to.
Because it's not equal to. So same concept, except instead when we graph this, it's not going to be a full line. It's going to be like dashed or like a dotted line because it's not including or equal to any of the points on that line. Okay, so here, if we have our point now, 1, negative 1, and then 0, negative 3, we could make this line, but it's going to be just a dashed line because it's not going to include any of those points because there's not an equal to sign there. Okay, I know, crazy concepts here.
It's not different, right? It's no different than this, except now it's just on a graph instead of a number line, right? If you had the equation y equals 2x minus 3, that would be a line. But this doesn't say y equals that. It says that it's less than that. So that line can no longer be part of the solution because if the line were part of the solution, that would mean that it is equal, but it's not. So we represent that as like the boundary. That's the same concept as the circle, right? It's like this is going to be our limit, but the limit is not included. So what would visually represent? What visually represents the solution of an inequality? What shows us the solution here? Right, so what part of the picture shows the solution? Is it just the 3?
3 and below.
It's like, it's this, right? This, you can consider that like shading.
Shaded area.
It's a shaded area.
Anything
So
below 3 is shaded area.
for that inequality, we know that the value of y is less than 2x minus 3. So it's not the line. How do we know which range we would go? Let's use an example. If we used x is 1 and y is negative 1, right, which you gave us as the point on the line, that would tell you negative 1 is less than negative 1. Is that true? Negative 1 is less than negative 1?
No.
No, so that's not a solution. That's why your line is dotted. It's not a solution. What other point could we try? We have to try something. Our solution is either the whole left side or the whole right side. What point do you think would be easiest to try? If you're not actively paying attention and writing stuff down, I'll tell you now, you are not being recommended for honors in high school because this is the basic foundation of algebra. If you can't get this, you're not going to honors in high school. So if that's your goal, then pay attention now and write stuff down. Is there a coordinate that we could probably easily try? Yeah, 0, 0, the origin. Right, very easy to substitute in.
So if we tried 0, 0, so 0 for x and a 0 for y, what would we get?
0 is less than.
Is that
Is
true?
0 less than negative 3?
No.
So that means that coordinate and all the other points on that side are not solutions. So what would the solution be?
The negative.
Which side of the line? The other side.
So this whole area, if we shaded this all in, we know, because we know none of the points on this side, because we tried this one, and it didn't work. So we know none of the points on this side of the line are going to work. So we know that it has to be this side.
That line is your boundary, right? So that line is like the 3-dimensional version of that. So when you graph just a regular inequality, you have the whole line, you found your boundary of 3, and then you had to try, right? When you do this, you see, x is less than 3. So it's only one direction. This is the same concept, except this is one variable, and that adds the second variable. But the concept's the exact same, right? So if you understand this idea, this won't be, it's a little different because you've never shaded a side, but it's still the exact same concept, which is why we tend not to spend significant time because we spend a lot of time graphing lines. If you look at y is less than 2x minus 3, just start with y equals 2x minus 3. Start as an equation, right? You could just graph the line and then say, well, wait, now it's an inequality and it doesn't include the equal sign, so this is going to become dashed. And then I need to find which side is the solution. So I'm going to try the origin, it's the easiest one, and it didn't work, so it has to be this side. So it's the same thing. Right? It's just showing the range instead of an exact. Because in inequality, if you have to be greater than 60 inches to ride a great adventure, 61, 62, 63, anything above, not just one value, that whole range counts. So this represents the whole range.
So when we graph systems, we're going to graph them on the same graph, just like we did the systems of just lines, the systems of inequalities, we're going to graph on the same graph.
And we'll
now,
talk about what the solutions of the system are after you understand just the graphing of the individual.
so right now we're just going to do one per graph, so I'm going to erase this. And if you didn't copy this example down, I would suggest copying the next one down, so you have it in your notebook, okay? So this second line.
If it was a line, how would you graph it? If that was just the 2x plus y equals 2, if it was an equation, how would you graph that?
I would put it in the slope form of y.
Okay, you could put it in slope-intercept form, subtracting 2x from both sides. So now how could we graph? If it were just a line, and again, because you already know how to graph a line, start with the line. Pretend like it's an equation, and then we can make our little adjustments. If that was y equals negative 2x plus 2, how would we graph that?
Can you do the origin first?
Well, let's just graph the line. So last time you recommended trying points on a table, which we could do. But let's do it a different way. How else could we graph if it's in slope-intercept form?
We can use the y-intercept.
Good. The y-intercept is what?
No.
Based on that equation, use your anchor chart. What's the y-intercept?
Two.
Here we go.
Y-intercept.
It's our y-intercept, which is what value in the equation? 2, right? In our slope-intercept form of y equals mx plus b, that b value is your y-intercept. What's your slope? -2. How can I show movement?
Put it on a page, maybe.
How would we move using the slope?
In increments of -2.
Okay, so explain. Where's our next point?
So if you're at 0, you go 1 at 1, which is your.
We're not at 0 though. We're at the coordinate 0, 2. So how would we move using the slope?
To the right 1 and down
Say it again.
2. To the right 1.
We're going to go over 1 and down 2, or some of you say down 2 over 1. So there's our line. So let's just start with the line. Okay, that should not be complicated for you. We did an entire unit on graphing lines. That part shouldn't be hard. Okay, if it is, then you need to come during lunches or after school and do some relearn, because that part shouldn't be hard.
So now, at this point, we need to figure out, because it's not this line. We just graphed y equals -2x plus 2, and we actually have an inequality here. Y is greater than -2x plus 2. So the first thing you have to consider, is this line going to be dashed, or is it going to be like a solid line?
Gustavo.
Yeah.
Why dashed?
Because of the two inequality. And you said if it has an equal, it has to be a solid.
Because that line is just the border. It doesn't include it. If it included it, you would have the equal sign, less than equal to or greater than equal to. Just like you would have the closed circle versus the open circle. So we know it's dashed. Now it's a range. So our solution set is one side of the line. We don't know which side, so we have to test the point. Which point do you want to try?
The origin.
Yeah, the origin is typically the easiest one, unless your line goes through the origin. If your line goes through the origin, then you would choose a point on either side. But in an effort to save time, the origin's so easy because whenever you substitute in a 0, it makes that part of the term 0. So this inequality becomes what?
So we plug in a 0 for x and a 0 for y.
So 0.
The 0 is greater than
2.
2. Is that true?
No.
If it's not true, then that side can't be your solution, so what would you shade? The other side, and you could shade the whole side. So again, the idea of graphing an inequality is really not, there's like two tiny things different than a line. We spend significant time on graphing lines, and then we just use that and tweak it a little bit to show you the difference between a line and an inequality. Does anyone have questions about why the line looks the way it does, or why we shade one side versus the other? Because those are really the two key differences between graphing a line and an inequality.
I don't really get how, why do we shade it?
Why do we shade it? Okay, that's a good idea. Let's talk about what this represents. Our inequality of, let's look at, if we look here, y is greater than -2x plus 2. Whatever values our solutions would make that true. So let's use some random points. We think that this whole side is our solution. So let's take some points here. What's a coordinate you see? Give me one. Go.
3.
3 what? The coordinate.
3.
Let's do 3, 0. Right? The point 3, 0, we think falls in our solution set. If x is 3 and y is 0, the is greater than -6 plus 2, which is -4. Is that true?
Yes.
0 greater than -4? Good. So this is one of our solutions. Okay. Let's try another coordinate. Who sees another one? What's another one? I mean, there's like thousands in there, but name one.
That's more than
0 is greater than -30.
Well, give me one of the coordinates in this range. Sorry.
4, 0.
4 and 0. So this point right here, we're going to try this. 0 is greater than, if I substitute a 4 in, it would be negative 8 plus 2, which is negative 6. Is that true?
Yes.
Yes, so that's one of our solutions. If you tested every single point on this side, they would all be true. So then what you'd end up doing is shading in each point would be on there, each solution. And that, which is why it ends up just being the entire side. You can test every single, if you really have the time, you can test every single point on that side of your boundary line and it would work. Every single point on the other side won't work. They'll all say like 0 is greater than 7. 0 is greater than 9, which that's not true. So that can't be an answer. So really, like when we show that like squiggly shade, it's really, imagine it, and you'll see real shading on some of the examples. Imagine each coordinate actually marked as a solution. It's just going to be a blanket of color because that whole side would work for the inequality. The difference is it's an inequality. We're looking for a range. Imagine the difference of like you have to be greater than 60 inches tall to ride a ride. Think about the thousands and millions of people that could ride the ride. But what if the rule was you had to be 60 inches exactly? Way less people, right? Because only 60 inches. But if you say more than 60, it's like everything greater. That's the difference between the line and the range. That's shading. Make a little bit more sense?
Yeah, shading because every point is true.
Because every point on that side would be true. And if one point on that side is true, they're all true.
So now we're gonna work on. Oh, this is. Okay,
We're
so
going to
now-
practice graphing, but we want to show you how it all gets put together first.
So this is the what we just graphed. We're gonna do it all on one now. So we can just talk about the system of inequalities, not just one inequality graph and the other inequality graph. We're gonna graph them together on one graph. So now you can see that there's like multiple. So we have two lines. There's like multiple regions. Here, there's all over here, right here, and all right here. So we want to talk about when you think about a system, like a system, go back to system of equations. What are we finding?
What was the solution? What was the solution to a system of equations?
The solution was when both of the functions are the same, or the two lines are graph intersect.
So let's specifically talk about the intersection, that point on the graph where they intersect. What does that coordinate represent? It's the coordinate what?
The line share.
It's the coordinates that they both share. So in an equation, well, with two equations, there's one. But in an inequality, how many do you think there's going to be? Many. So think about the solutions. Which line was which here? The line that's going down, is that the top equation or the bottom? Okay. So let's just reshade what our solutions were. So like equation 1 is the one that's going up. So let's go back to our solutions. Where was our solution for that first line? Was it like to the left or to the right?
This or was it all of this?
Remember, 0, 0 did not work because when we plugged in 0, 0, 0 less than negative 3, not true. So we shaded the whole right side. So we're going to shade it in red. We're going to shade that in red.
All of that.
And now in black, we're going to shade the solution of the other one. So that second graph, did 0, 0 work?
0, 0 work. This side work?
No.
It was all of that.
So let's shade that
So we
solution.
shaded this whole side.
Which coordinates do they share? Where do you see it? Where is the system visually? You had to explain, like, the system is here. Where would you explain it?
Like the systems where both them, the shaded area where they both meet. Oh, that shaded area where both of them
Yeah.
have the same color.
It's when they overlap.
And they overlap. So if we took away now, because this area is all of these points are a solution to where? In this area.
Only one of them. Good.
Only one of them. So we could just
We can erase
so
that.
we could erase that because we're looking for both.
The solutions for both.
And this area is a solution for just one of them. So we're looking for both, so we could erase that. So now we have shaded. What we have left is the shading where it's a solution to what? To both of
Their
them.
solution's full.
So this, all of this whole area, this whole section is a solution. Every point in there, if we try this point, if we try this point, if we try this point, they will be a solution to both of these inequalities.
Which means it's a solution to the system.
What would the equations look like? You know, like after.
Like, do you want to try one?
Yeah, because I mean, like after you.
Okay,
find-
so you're not gonna have like X is this and Y is this. When you solve a system of inequalities, that's your solution.
So like you say, like
Nope.
you write that
It would be a
down.
graph.
Alright,
You would
cool.
graphically, or you could find, like in our first example with the ringtones, you could find different values. Like maybe you'll have a question that's like, give 3 examples of the premium ringtones that you could buy and the top 10 ringtones you could buy to stay under $15. But primarily, a lot of your systems of inequalities will be graphed like that. And then maybe once you graph it, they'll ask a follow-up question. Like, so-and-so wanted to buy 13 ringtones of top 10 and 3 ringtones of whatever. Like, could they do that? That might be your follow-up question, but typically it's just graphically because that goes on forever. Right? So you're not going to be expected to explain the way that graph changes and, like, grows. You know what I mean?
So if you don't have this example in your notebook, put it in, please.
This is a good one to have, especially with the shading. And we know on the smartboard the shading is tough to follow. When you use a pencil, you'll see it much more clearly if you shade like one section really light and then one section with like a different shading of lightness. You'll see where they overlap pretty clearly. Colors work too. For those of you who are really visual, you could do like a light yellow and a light blue, and then when your thing turns green, you know that's the solution. Like, right, blue and yellow is green.
So in between the solution.
The points that they share.
Yeah.
Yep. So the overlapped shading.
So all
And like
the
the
red
visual on the
and-
next slide, like is from the textbook, it shows you. Now this is not in your workbook. Systems of inequalities are not taught in 8th grade. So you would see this if you need extra help in the textbook. Okay, it's chapter 6. Systems of inequalities are in here in the text, which you guys should have at home. The hardest part is really just getting the graphing down, but if you make the connection to graphing a line, then you'll be fine and you'll pick it up much, much faster than if you had never graphed a line before. Yes.
So if you saw a problem like this, you would just explain that. As you can see on the graph, the
The graph
two
would
ranges.
suffice.
Yeah.
The graph would be your answer. You
Oh.
most likely wouldn't have to explain, again, beyond asking a specific question. If you had to give a value that they shared, you could. But like, if you see it on a test, you probably are just going to be asked to graph the system of inequalities and show the solution. I know on the park there is a question where it's like, they give you the 2 inequalities and you actually have to like create the line. So because the park, you know, is interactive, they allow you to plot the points and then you can decide if the line is solid or dotted. You actually create that, and then you click the area, like you would solve this one with certain shading, and like it's actually interactive, so they have you do the whole thing. That is a part question for 8th grade. No, for 9th grade, because they don't learn this in 8th grade. That's an algebra 1 part question.
Oh, so they don't let us do the 9th grade one too.
I'm sorry.
They don't let us do the 9th grade part too.
No, you do. You take algebra 1.
Oh.
I mean, so like that would be your part question.
Okay. So now let's take a look.
We already kind of went over, but we'll show you the solution. So if you look here, there's like yellow and blue were the solutions of each individual one, and I know the one on the right is actually green. It's where they overlap. This picture is really, really nicely laid out in your textbook to show you where they share. So this, they show you that you could check a point in each section, which you could, but like it's really time consuming to do that. If you've already solved both inequalities, you're kind of given the solution. If you're someone who loves to be very methodical, you could go back and check something in each, but you've kind of already done that if you've shaded each individual inequality. Okay, so this kind of just shows it again.
Yeah, they show you just check
Another way to check.
each section,
Yes.
but you can just check.
There's a question mark in the end. Or is it just like
It's asking like, is 0 less than -3? That's they're just visually trying to show that it's like we have to figure out is it true or not.
Okay, so now we're gonna graph this one, sorry.
Should we get, no, you're saying exactly what should we give.
Yeah, so we'll give our graph paper.
We're gonna give you graph paper because we know sometimes that it's easier to see when you're graphing. So keep it in your binder or your folder if you don't have a binder. But again, when you're looking at a system of inequalities, treat them individual first. But if you're doing them on the same graph, they're going to obviously be put together.
We're gonna use this for like the rest of the class, so don't like take up the whole page for one graph.
Yeah, we're gonna do a little activity with it. With the graph paper and stuff.
So notice these ones are less than or equal to and greater than or equal to. So think about what the line's gonna look like, if it's gonna be dotted, or if it's gonna be like a solid line.
So we do this.
So where you're shading, it's the same color. If you're gonna use the color to show the solution, that would have to be the same color. That whole area, like it's gonna, the blue, your blue and red are actually in the right spots. Yeah, if you need to brainstorm together, but graph the first line, finish that solution set, then graph your second line, graph that solution set.
You can see the points that are